Hey everybody, welcome to CSE 447, Concepts of Programming Languages for this quarter. My name's James, I'm going to be your instructor, and I just want to walk you through sort of how the course is going to work and what it's all about. So this is an intro video. If you come to the course on D2L, you'll see, hopefully, what I see before me right now. There's a welcome message here, and a notice that we're going to be meeting at 5:45 p.m. on Zoom. So we've got Zoom meetings scheduled, and you can find those in the calendar down below. And right here is a link in the important links section to our Zoom classroom. You'll also see in this welcome message a link to this video, which you are watching right now. So if you want, you can recursively watch this video over and over by clicking that link now. But if you want to make progress, don't do that. Just stick with it. We'll keep going forward here. So there's the welcome for you. Welcome. And here's some important links. So I've got a link to lecture materials, to a discussion forum, and to a Zoom classroom. So I ran this course online only for the first time in spring, and it worked, I think, very well. And the way we're going to do it is I will pre-record material for you and put it up on YouTube. And then we'll have live discussions every week where you can ask questions, we can have chit chat, I will go through homework solutions, etc. So those will be on Zoom. And so the idea is you are going to watch the lecture hopefully before the Zoom meeting, and then we can have a discussion there in class, and I'll walk through how to see the lectures and so on presently. So the links here are for, again, the lecture material, discussion, and Zoom. For discussion, we're going to be using an application called Discord, which you can just fire up. And when you click this link, Discord will offer you the opportunity to join the 447 server, and you should accept it. So just click on accept. And then when you fire up Discord, you should see a link here over in the left-hand side to participate in the class discussion. So this is a chat app. It's quite a good one. I liked it. I used it in the spring and it was very successful. One important thing I want you to do is to make sure that I have your real name here. It's quite confusing for everyone if the names are arbitrary rubbish. So please, right after you come into Discord, come up to this little click box and come down here and change your nickname for this server to your real name, first and last name. First name can be whatever you like to call yourself. Last name, please make it whatever it is on Campus Connect so I know who you are and I can connect. So this will be our discussion forum, and we'll talk more about it as we go forward. Discord's great. So, and Zoom, hopefully you've used already. I'm sure you have, and you can just click here to get there. So the main thing I want to go through then is to look at where the lecture material is. So if you click that link, it'll take you to this schedule page, and here you can see the weeks broken down and the lecture material here week by week. Most of these videos I'm going to reuse from the spring, so I won't modify them dramatically. There's a few, I think, in weeks maybe 4 or 5 that I'm going to change. But for the first couple of weeks anyway, you can just go ahead. So you can see here there's some amount of material here for week 1. And what you're watching right now is the overview. So if we click on this, you'll get some slides. So these slides are done with Reveal.js. So this is a JavaScript framework for creating presentations. And if you're curious about it, you can click here. The important thing for you to know is that there's some keyboard shortcuts which are quite handy. It should work on your mobile device as well, so you can flip through with your finger to go from slide to slide. But if you're on a keyboard-enabled device, you can use Q to come back to the schedule page. You can use Z to print the slides. That will work only on Chrome, by the way. So that'll give you all the slides on one page. It doesn't work in other browsers. And there's a bunch of other keystrokes that are available. So if you just hit the question mark, you can sort of see them. So as you're going through the slides, that might be helpful. Okay, so some in particular, the space bar moves to the next slide. The cursor keys also go backwards and forwards. Up and down might be useful in some contexts. And the escape key gives you an overview of the slides at any point. So let's just look at these slides that we're going through now. So if you click on it, you'll see a slide and you'll see this little arrow here. I can just click the right arrow, and right after the title slide, you'll see an embedded the video for this week or for this lecture. And so these are done up on YouTube, and you can watch it in line here, but probably most of you don't want to do that. More likely you'll actually want to watch it on YouTube. And in fact, the best way to watch things is to look at them through a playlist. So I've created a playlist for the course, which if you click will come up in YouTube. The nice thing about this is that if you are logged in to YouTube, you'll get progress. And this is really key for being able to sort of watch segments of the videos. Some of these are sort of long. If it's a 40-minute video, you may not want to watch it all at once. So you can, as long as you're logged into YouTube, it'll keep track of your progress, just like Netflix or anything. So you can start back where you were. So anyway, this is the syllabus video that I'm going through right now, and I'll keep them in order so you can just sort of go one at a time through these. Then you might want to have your video up and then be able to go through the slides or look interactively at another window where you can, if I'm talking about something that's interesting to you, pause the video, go maybe play around with Scheme or Scala or whatever programming concept we're talking about. And that way you'll stay engaged, because, watching a video all day can be a little dull, and nobody wants to bore you. So the whole idea here is to take advantage of this format. There's some great things about having an online only course. One thing is that I won't spend so much time faffing around because I can edit out the boring moments where I don't know what I'm talking about and I have to back up and I have to rephrase it. So those things I can edit out, which is great. And it also gives you the opportunity to pause, to watch the video in pieces, and things like that. Another thing that's nice is that YouTube does do closed captioning. And so if you're in the YouTube environment, you can do closed captioning and see, those things there. By the way, YouTube also has the ability to put tables of contents into videos. And I will do this for some of the videos for this course. So I'm not sure, it's not done for this one. But on some of the videos, there will be comments below. And if you look at the comments, you might find a table of contents, which is clickable. So if there's a particularly long video in sections, I'll put video contents there so you can click around and randomly access different parts of the lecture. Okay, so that's how you'll be able to watch videos. Note that YouTube also has some great features for playback speed, for example. If you're all hepped up on caffeine or sort of drugged down on barbiturates, whatever it is, whatever speed you need, you can find it here. You can speed it up, you can slow it down, whatever works for you. And of course, YouTube also has the ability to check your quality. So note here it's showing at fairly low quality, but all of these things are recorded at 1080p. So as long as you're on fast enough connection, you should be able to get all these videos at high quality. Okay, so just look here at the YouTube controls for those things. All right, so that's how you'll watch the video. So what's this class all about? This class is about programming languages. So we know what programming is. We write programs to make computers do things. We also write programs to communicate ideas to other people. And we write programs that get maintained over long periods of time. So there's lots and lots of different places where programming happens. Programming happens in your refrigerator. Programming happens on websites, on Facebook, on your phone. I mean, it's happening everywhere. And so why would we pick a particular way of expressing ourselves to do a particular task? That's the area that programming languages is sort of looking at. So you're used to certain concepts of programming like while loops or for loops or recursion. Those are concepts. There may be other concepts that are slightly less familiar, like closures or list comprehensions, pattern matching, dynamic dispatch, mix-ins. These are all things that I suspect are less familiar. So that's one of the goals of this class, is to get you familiar with these concepts, which happen to be very fashionable right now as well. So we're going to do quite a lot in the closures functional programming area. Most of you are probably more familiar with the object-oriented paradigm. And so we're really going to drill into functions in this class. Functions are becoming increasingly important, particularly for mobile and web applications. So we're also just going to have a deeper understanding, hopefully, of programming language concepts in general, and look at sort of the effect of the choices we make of programming languages in terms of how they support development modularity, the correctness of programs, the efficiency of the programs, etc. There's some non-goals for this course. We're not going to try and talk to you about a language that's really similar to the ones you already know. Instead, we want you to learn concepts that are interesting so that you can actually assimilate new languages relatively easily. So we're going to also not have the goal of learning how to use some sort of integrated development environment. We're going to be instead looking at command line tools for the most part, and looking at a range of tools and build systems that might work for you. So the idea here is that we're looking at paradigms and styles of programming. So for example, functional programming versus object-oriented programming. That'll be a big emphasis. Also, mutability versus immutability. So when I write my programs in, I can write them in the style where I've got variables that are changing state constantly, or I can avoid that and write it in immutable style. So we'll talk about the trade-offs between these, between iteration and recursion, between pattern matching, visitor pattern design, and different styles like this. So these are different ways of writing programs that it's important to be familiar with so that you can make sensible choices going forward. In the process, we're going to be looking at some basic ideas of how you implement languages. And one of the most important ones is where data goes and how we manage the store. How do we manage memory? So there's different ways of thinking about lots of stuff. So there's scope, there's layout of the stack, there's object implementation and closure implementation, and how we deal with nested functions and objects. What does garbage collection mean? All of these ideas hopefully will be clearer by the end of the quarter. And finally, we're going to look at analysis of programs. So one of the things that computers do is look at computer programs and make conclusions about them. So you're of course familiar with the idea of a compiler. So a compiler takes a program and turns it usually into a binary that can execute on the machine. So if you're running Java, for example, the Java compiler produces bytecode, which is a sort of binary format that's interpreted by a Java virtual machine. And that compiler is doing some analysis to determine whether or not the program is okay, whether it's syntactically valid, whether or not it has the right types around in the program, everything is declared properly, etc. And so that's a kind of static analysis. So this is an analysis where the compiler is doing something before the program runs. There's also dynamic things that can happen, dynamic analyses. So dynamic type checking in particular is something that we'll talk about. So these kinds of analysis are important. So we'll talk about some basic ones. Okay, this is a really hands-on course. We're not going to do a bunch of airy-fairy theory. We're just going to get our hands dirty and try and write some programs and run some experiments. And I'll show you the setup we'll use for that. We're going to be using primarily one language for the core of the course. That'll be Scala. Scala is a wonderful language. It's a broad spectrum language. It's got objects, it's got functions, it's got lots of stuff. It's very carefully designed, which is important for us because we're talking about language design here. The textbook is also fantastic. So if there's any book you should read on programming languages, it is the book that we are requiring, which is the Scala Programming Introduction from Odersky and et al. So I'll show you that in a sec. There's also other languages we're going to look at. So we're going to look at C, C++, C#, Java, JavaScript, other languages which are chosen mostly because they exemplify certain concepts or allow us to talk about certain concepts in a way that is difficult sometimes in Scala. Scala can't do everything. And in particular, we'll be looking at C and Java early on and talking about those languages because I will presume that those are familiar to you. Those are prerequisite languages. Okay, so here's a slide just to talk about the discussion forum and how you go about changing your nickname on that forum. Of course, the discussion forum is, we have a diversity of people in class, and so please use appropriate language and everything. No trolling, don't be a jerk online. And the final slide here is talking about the syllabus, and so that's linked from the course homepage. So what I'm going to do here is simply hit the Q to get out of the slides. And now I'm back to the schedule. And this is the homepage for the course. You can see here that I have a home link, and there I've got a link to the course syllabus. So let's just walk through this briefly right now. Like I said, I'm James, and I'll be your instructor, and you can find my personal info or stuff about my research, etc. here. This particular course is on the course homepage listed here, and we're using D2L as our learnage management system. So for this course, the prerequisites are data structures 2 at DePaul. You should know about trees and graphs and things like that. And systems 1. So that's requiring to make sure that you know assembly language. We will be assuming that you know assembly and C and Java. So you don't have to be a master of C or a master of Java. We're just going to talk about some specific narrow parts, but I don't want them to be completely unfamiliar. If they're completely unfamiliar, you will be unhappy. So the prerequisite skills here is that you have done some Java and C programming. You will not be using an IDE for this class. So instead, what I want you to be familiar with is using some sort of command prompt. And you'll see I have a worksheet for you for week 1, which will help you with a command prompt if it's not familiar to you. So we have a couple of textbooks. The first one is a Concepts of Programming Languages textbook. There is only one edition of this book. It's sometimes, though, the bookstore thinks there's a third edition. It's fine. Just take any edition of this book because in reality, there's only one. So if somebody's saying it's a third edition, don't worry about it. Just take whatever it is. Here's the direct link from the publisher. And if you buy it from the publisher, it's a little pricey. It's also available on Amazon as a Kindle version. I think the Kindle version would be fine. It's a little cheaper. And you can rent it on Amazon as well. So there's the first few chapters available via Google Books. So if you want to just read the first little bit to get a sense of it, you can read it there online. The other book is Programming in Scala by Odersky, Spoon, and Venners. It's a fantastic book, and I highly recommend that you get this thing. I actually like the e-version a lot. So if you buy it direct from the publisher, you'll get you can get the ebook and paper for $70, or just the ebook for $30. Up to you how you want to read it. It's a great book, and the ebook is actually quite nice. It's nice to have. So and if you buy it directly through the publisher, you get the PDF. You also get the other kinds of versions of the book that are readable, like on an iPad or on a Kindle. So quite a nice deal there. So that book, very, very important, Programming in Scala. The concepts in programming languages, it's a general intro, and it's useful particularly, it's useful to you particularly if you're somebody who likes to read books. So, but I think it'll be useful to everyone. All right, it is possible to do this course without this, but it's a helpful backup, I think. So required for the course. So please, do get it. But if you're someone who doesn't like to read books anyway, maybe you can share with someone. Okay, a comment about Programming in Scala. You can use any edition of this book. I think it's nice to get the most recent one because it's specifically for the current version of Scala, and it will be better. But it is sufficient for you if you want to avoid that expense to use the first edition. Personally, I don't recommend this. I would say just go ahead and spend the $30 for the online version of the Programming in Scala 4th edition. In order to come up with a final grade for the course, we'll use the following formula. We'll have 20% for homework assignments, 15% for quizzes, 5% for worksheets, which I'll show you in a sec, and then 2 exams. The exams will be multiple choice, and they will be cumulative. And we'll be doing this all online this quarter, so it'll be straightforward in terms of they're going to be multiple choices exams online. Okay, and then there's some generic policies here, so please just read these. I won't bother to go through them now. If we return to the homepage, I can just walk you around the rest of it. So there's a link here to Discord, the syllabus, to Blue Star, and to tutors and student services at DePaul. If you need more time for exams or things like that, please contact student services. There's a resources page here, which has a bunch of links, which we'll be talking about as we go forward in the course. A little discussion just about the textbooks we just walked through, a little information about me, which we also walked through, and finally the most important link, which is the schedule. So here you'll see divided into multiple areas, the reading for a given week in the Concepts of Programming Languages book by Mitchell, and the reading in the Programming in Scala by Odersky et al. So this is what you should read this week, preferably before we meet. And there's also the recorded lectures with corresponding slides, so as I've already shown you. And they sort of go in order. So ideally you'd have watched at least half of this before you come to class, preferably all of it, but at least half of these videos, please. We'll have a more productive discussion, and you'll get more out of the course if you've actually done some of this work before you come to class. So try for this week at least to get through all of this business on C, and ideally a little bit through Scheme, if not all of it, before we meet on Wednesday on September 9th. So the other thing that you'll see here is some worksheets. So there'll be worksheets every week, and these usually there's one, maybe 2 per week. So here I have one worksheet on Java and C and another one on Scheme. So if you click this, it'll sort of walk you through some basics. And the first thing is just for those of you that are not familiar with the command line, there's some stuff here on the command line. If you're already command line competent, don't worry about this. Just don't even bother to read it. But here, if you walk through a little bit about Java, you can see how it works. And you can look at a C compiler and just see how it works. So this will help you get up to speed and so that you can actually play around with C examples either natively or through an online read-eval print loop. So this is one read-eval print loop called REPL-IT, where you can go about just typing your code in online and not necessarily worry about having to install tools. So try these things out. You've got some homework problems here to try out. Note that in the case of the worksheets, I'm giving you problems with solutions. So the idea is that this is a guided process where it's sort of encouraging you to explore how these languages work, and it's kind of intended to get you into some sort of organized play. So nobody learns anything if they're bored, and so it's great for you to be engaged. I hope these worksheets are engaging for you. That's what they're intended to be, and to help you sort of get into the material in a more what do I want to say? A less passive way, a more active way. Yeah. So you're actually actively involved, playing with the language and understanding how it works. The second worksheet is on scheme, and you can see here there's some stuff about further stuff about Java and C. But then when you go to Scheme, you can see here there's a section on using Scheme online if you want, or installing it on your home computer, and then some exercises using Scheme. So let me just show you what it looks like online real quick. If I go to Replit for Scheme, what I get is an editor on the left and runtime on the right. And you can just sort of type in some Scheme expressions here and then run them, and you'll get the output on the left. Let's try it again. There we go. For some reason, it doesn't seem to show the output correctly the first time, so try it twice. That's the Replit. You can also, of course, install it on your home machine. There's different ways to do this on different operating systems. So that's the idea of the worksheets. Once you've completed the worksheets, then you should go ahead and do whatever homework there is for that week and complete a quiz. You'll see those things on D2L. So at the bottom of the page here, there's a link to D2L, a link to the YouTube playlist, a link to the invite for Discord, and just a link to send me an email. So on the pages here, you can just click any of those things. If you go to D2L, you'll see the homework and quizzes listed every week. So for the first week, the homework assignment is to simply do some Scheme. So you should download this file, complete it, and then re-upload it here. All right, well, that finishes this brief intro. Let me know via email or on Discord if you have any questions. Please sign up for Discord as soon as possible. And if you can make it into the Zoom class on Wednesday, it'd be wonderful to see you there. Like I said, it probably won't be very long, and it will be recorded, except for breakout rooms. There may be breakout rooms and a little chit chat at the beginning and the end, which won't be recorded, but the substantive part in the middle, I will record everything. Okay, hope to see you soon.